mynews.studio.
A ring-shaped molecule with 13 atoms, sulfur and carbon, has been found drifting in a starless cloud. This could reshape our ideas about where life begins.
Today's date is 2026-03-01. Let's get right to it. Scientists have just identified the largest sulfur-bearing molecule ever seen in space, 2,5-cyclohexadiene-1-thione, or C6H6S. Why all the fuss about a molecule with just 13 atoms?
What makes this special is that it's the first time a complex ring-shaped sulfur molecule has been found in the interstellar medium. Up until now, astronomers only detected smaller sulfur molecules, 6 atoms or fewer, in space. But comets and meteorites from our solar system always showed more complex sulfur molecules. So there's been this puzzle. How do simple molecules in deep space become the complex organics we see closer to home?
So, this molecule helps bridge that gap?
Exactly. Finding C6H6S is like discovering a missing link in the chain. It demonstrates that complex organics, including those important for life, can actually form in space, even before there are planets. This particular molecule was detected in a starless young molecular cloud called G+0.693-0.027, near the center of our galaxy, and that's about 27,000 light-years away.
That's a huge distance. But how do scientists know a molecule like this is really sitting out there in space?
Right, so it starts in the lab. Scientists took thiophenol and hit it with 1,000 volts to make C6H6S. Then they measured its radiofrequency signature, basically its unique molecular fingerprint, with very high precision. They then compared that fingerprint to data from large radio telescopes in Spain, the IRAM 30-meter and YEBES 40-meter. The patterns matched perfectly.
So now, we know these bigger, ring-shaped sulfur molecules can exist in space. But why is sulfur so important for life?
Sulfur is crucial for proteins and enzymes. It's a key player in the chemistry that makes living things possible. And what's striking here is that even in cold, dark clouds in space, complex sulfur organics can form. This discovery pushes the timeline for life's chemical ingredients back billions of years, before stars formed, before planets existed.
Wait, are you suggesting that prebiotic chemistry, the stuff leading to life, begins out in space and not just on planets?
That's what the data point to. The cloud where C6H6S was found is young and starless, the same kind of environment that our own solar system once formed from. These molecules can assemble long before planets even show up. So the building blocks for life seem to start out in space, not just on worlds like ours.
Does that mean the universe could be filled with these prebiotic molecules?
Most likely, yes. C6H6S is just one example. There are probably many more complex sulfur-based molecules drifting in interstellar clouds that we haven't spotted yet. With new telescopes like the James Webb, we're even picking up smaller organic molecules, benzene, methane, acetylene, in very distant galaxies. It almost seems like galaxies themselves are producing a variety of organic molecules.
If these ingredients are common, does that raise the odds of life developing elsewhere?
It does. These molecules aren't alive, but they're the chemical starting point. If they're widespread, then the raw materials for life could be too.
So what does this mean for future space missions? Should we be searching for these kinds of molecules as biosignatures?
Absolutely. If we're searching for habitable worlds or signs of life, detecting these complex organics is a strong sign that the chemistry needed for life is already underway. It could mean a planet already has a head start towards becoming habitable.
So, just to sum up, this isn't proof of life itself, but it does show that the universe is much more ready for life than we once thought.
Exactly. What we're seeing is that interstellar space is putting together the chemical toolkit for life, and it's happening far from any planet or star.
That's a big change in how we think about where life could begin. Thanks for making that so clear.
Thanks for joining us as we traced a tiny molecule's connection to the broader story of life in the cosmos.
The universe seems a little more welcoming, and perhaps a bit more ready for life than we imagined.
Thank you for listening. This episode was brought to you by mynews.studio. You can try it now for free.